Okay, so let's go to the moment of a force. So in physics, so the term moment in physics is actually torque. So if you're familiar with torque, so this is what the topic is all about. So we're just going to discuss torque. But usually in engineering terms or engineering mechanics terms, so the torque becomes the moment term from engineering, in engineering. So moment. So usually this is what we are calling our twisting and bending forces if we analyze our structure internally. So bending, shearing, twisting. So that's how we analyze our structures through the behavior of the forces being applied. Okay, so what is moment? So it's the measure of the capacity or ability of the force to produce twisting or the turning effect about an axis. So notice in the description, so it's more likely the same as your physics description, twisting and turning effect. And of course, the axis is perpendicular to the plane containing the line of action of the force. So if we try to analyze the first sentence, so the axis is perpendicular to the plane of action. So for example, this one is your axis. It's perpendicular to the plane, di ba? Perpendicular to the plane containing the line of action of the force. So this one is your plane, kaning murag papel, di ba? And then that plane is perpendicular to the force. Okay, about a certain point. Okay, the magnitude of the moment is equal to the product of the force times the perpendicular distance. So most likely our unit for the torque, so again the same as your physics topic. So the unit is Newton per meter or kilonewton per meter because again that's force times distance, the perpendicular distance. Okay, so the intersection of the plane and the axis is commonly called the moment center. So this is the moment center. So in this figure, that's the point O. That's the moment center, the intersection of the plane and the axis. Okay, the axis, y-axis, and then the plane, this plane here, the one in red. That's the plane area. Okay, so the perpendicular distance from the moment center to the line of action of the force is called the moment arm. So the perpendicular distance, this one d, is what you call as the moment arm, and this one is what produces the degree of the twisting or the turning effect of um, your body. Okay, so the shorter the distance, so I think the twisting is not really effective. Or so let's say if you have a 10 kilonewton force here and then you have a distance of 1 meter. So I think the twisting is very minimal compared with a distance of 100, let's say 100 meters. Then you have a 10 kilonewton force, di ba? Because again, if based on the description, so force times distance, so this gives us a 1000 kilonewton per meter moment. Then this one gives us only a 10 kilonewton per meter nga moment. Okay. So usually your formula is force times distance, and our moment is being represented as m, the m variable, capital M. So kana force times distance. So usually in the examples that I'm about to show you, so the The resolving of forces into its vertical and horizontal component is important because since we'll be dealing with the distance, perpendicular distance with the force, so I think if we're going to analyze a diagonal force, so the distance should be perpendicular to that force, di ba? So dapat ani siya, di ba? This should be the distance, but since it will be harder for us to determine the inclined distance, so the best option for us is to resolve this force into its vertical and horizontal component. Okay, vertical and horizontal component, and then we derive the moment. So we have a vertical, I mean a horizontal moment arm, and then the other one is a vertical moment arm. So ma-appreciate nyo later once I show you the examples. Okay, so moment of a force. So I think this murag pina-physics gyapon siya. So when a force is applied to a body, it will produce a tendency for the body to rotate about a point that is not on the line of action of the force. So notice that the the behavior of the point or of the body will rotate, but it's not in the direction of the force, but diri siya dapita, di ba? So the force is going this way, but the behavior of the material is twisting, di ba? So it's not also going in that direction, but the behavior of your material is twisting. So unlike pushing, so for example, you're pushing a box. So if you push a box, di ba, it will go forward, but that's horizontal force. But for moment, so since moment of a force is different, so the direction is going this way, but the behavior of the material is rotating. So it's not in the line of action of the force. Okay, so if a force is applied to the handle of the wrench, it will tend to turn the bolt about the point 0 or point O. Diba? Ano siya? Okay, so the magnitude of the moment is directly proportional to the magnitude of the force and the perpendicular distance of the arm. So as what I have told you earlier, so the greater the force and the greater the distance, so you can generate a huge amount of moment or torque. Okay, so note that if the force is applied at an angle of 90 degrees, then it will be more difficult to turn the bolt since the moment arm is d theta, I mean d prime is equal to d sine theta will be smaller than d. So what does this mean? Kani siya, diba? So for example, our point of application of in this area is not 90 degrees. So the force and the moment arm is not in a 90-degree angle. So the force created is less efficient, diba? So most likely it will turn the bolt, but of course it won't turn the bolt completely. So, diba, if you're repairing, let's say if you're repairing kanang na mga screws, diba, kanang mga how do you call sa man mga kalimot ko si term ni kaning mga hexagon na mga kuan na mga balls, diba nya you're going to use a wrench na, diba? So, diba, for you to be able to rotate that bolt completely, kay it should be in a 90-degree angle, diba? I mean, your moment arm. So, let's say this is your, si tawag ka na gani, I forgot the name. Magana, diba? So, diba, it's easier for us to rotate this bolt if the force being applied to the bolt is in a 90 degrees with the arm of the wrench, diba kani siya? So, what the fourth statement is implying is that, for example, you're going to apply the load in a different angle, na siyang angle. So, meaning the the efficiency of the bolt rotating is lesser compared to the 90-degree angle application of the force. So it's better that the moment arm should always be perpendicular with the force being applied to your system. So this is the fourth statement. This is what the fourth statement is implying. So, so it's less efficient if you're going to apply your force, diba? As you can see, you have an angle theta here. It's not 90 degrees. Compared in the first figure, the force and the distance are in a 90-degree angle. So let's say you're going to apply it in with a certain degree of angle, diba? So magdili siya efficient compared to the 90-degree point of application. Okay, so if the force is applied along the moment arm, so notice that this one is our moment arm, D, and this one is D also. So let's say the force is parallel to the direction of the moment arm. So as you can see here, the distance is in this axis, and the force is also in this axis. So notice that in this type of example, we're going to generate a zero moment or a zero torque because again, as per definition of your moment, that will be force times the perpendicular distance. So in this one is, for example, this one is the force. So our perpendicular distance should be in the other axis, diba? But since our perpendicular distance is not present in this figure, so most likely your moment is zero. Okay? So I think you can also imagine that if the behavior of the material, if it's going to twist or not. So in figure number 3, since you are pulling, so it's impossible for point O to twist or to rotate, diba? So ana ra pud siya nga kanang kuan nga simple explanation. So aside from the distance and the force being parallel, so of course you can also imagine the system if it's going to rotate or not. So again, since the figure is pulling, so most likely there will be no twisting that's going to happen in the system. So that's why in shortcut terms, in our shortcut terms in engineering, so if the force is parallel to the direction, with the moment arm or with the direction, so most likely the moment is zero. So as long as it's torque, you know the concept of torque, so that's the same as moment. Okay. So usually the magnitude of the moment is again in this formula. So the unit is Newton per meter, or in English it's pound per foot. So usually naputay pound per inch, and in the metric system we also have kilonewton per meter. So it depends on the application, the units being presented in the problem. So usually the original formula is m is equal to force times distance, and usually we're going to add up a subscript in the m in what particular point you're going to create your moment. So for example, in this figure, since we're going to take moment about O, so that's why that's m sub 0. So if you're going to take moment about A, so of course, mo change po siya, may mo po siyang m sub A. Or let's say you're going to take moments about C. So m sub C. So usually in a system, so since there are many points to consider, so that's why you can compute the moment at different points. So especially in a building structure, so for example, a roof truss or a slab or a column to beam connection. So since there are many points to consider, so of course, muna siya ang purpose ani. So you can have moments about this point, moment about that point, etc., etc. Okay, so I think that you're familiar with the right hand rule. So maragna na sa inyong physics, di ba? So the index finger and your middle finger should create a 90-degree angle. So you can imagine the twisting and turning with that figure. Na, diba? So pili po siya katong kaning nasa figure kaning thumb ninyo. I think this one is what is taught in physics kani siya. Okay, so usually ako nang i-pares ato. So kana force times distance, then the twisting and the moment ana ang kaning moment sa kaning kuan kaning thumb rule is murag kuan lang siya kanang you are going against the I mean you are imagining already the twisting action. So katong akong gidrawing nga index finger sa atong sa suwayo kuan na murag atong suwayo gibabaw ko mo drawing na basta magana siya nga kuan. So ato ino na mo ni itong index finger na ato lang kuan na basta mo na siya na. So for example, muna itong index finger, then muna siya ang ato ang I mean, muna yung index finger, muna siya ang middle finger. So usually, muna siya ang force. I mean, muna siya ang force kani. Kanya, muna siya ang distance kani, distance. So distance and then force. So for example, in the figure, so since this one is the force, this one is a distance. So if you try to rotate it, it's rotating clockwise, di ba? Or pili sa din yung balihon sad. So for example, the force is going to the right, so you can use the left hand, di ba? Left hand na sad mo, you create a letter L. Letter L na sad na. Sa kamo na ibala sa kamot na. So force and then distance na. Okay, so kanang thumb rule, right? Thumb rule is of course since you're already I mean you are already imagining the twisting moment. I mean twisting behavior of the material. Muna nagana siya nagkuop siya daan, di ba? Basa muna dire. It's rotating counterclockwise. So again, the point of determining the moment is, again, you can determine the behavior of your material. So twisting and bending behavior of your system. So for you who don't know what the application of this topic is, so usually when we go to our design sa engineering, so I think you can also reach this particular subject later on in your years, kanang structural nga subject. So reinforced concrete. So usually, for example, for example, you're in the second floor and you have a slab there, or you have a beam in your second floor. So of course, that particular structural member will be experiencing some bending or twisting moment because again, in reality, your system is being exposed to X, Y, and Z forces, especially if we're going to put into the concept of the earthquake load. Diba? So, labi na yung earthquake, diba? So, mag-twist-twist na yung mga building. So, muna siyang one application of this topic. So, usually in our higher years, up until we graduate, so we are still going to solve for the moment. Yan, daghan lang siyang term sa mga. So, ultimate moment, nominal moment. Okay, so let's go to this one. So, for example, you have multiple forces that you need to analyze, and then you'll be getting the resultant moment. So, of course, all you have to do is to solve each moment per force, and then you add them up in the final part. So, usually, ang mga moment na magbangga will subtract each other, and ang mga moments nga same og direction will add up each other also. So for us to be not confused on how we're going to do with our convention, so all counterclockwise moments are positive and all clockwise moments are negative. So in the figure, so we can say that we can add up force the moment of the force being generated by force 1 and force 3, since as you can see, you can say that they are moving in the counterclockwise direction. And for force number 2, so notice that if you're going to imagine the rotation, so it's clockwise. So we can say that we can add up force the moment of the force 1 and force 3 and then subtract the moment of the force by F2. So that's why in the formula, so usually we represent so the moment, the resultant moment, M sub R about O. So that's why it's written that way. So the moment of R about point O. So again, that's important because again, since we're going to solve for different moments in different points, so that it's important to indicate where you are referring your moment at. So again, force times distance coming from from F1, then minus. So take note minus since the direction of the moment is clockwise. Then we add up again since the direction is the same as the moment of force 1. Alright, so for you to be able to appreciate the concept, so let's go to some examples. Okay, so moment about moment about O. So in figure A, so this is the force, so times the distance. So moment about O is equal to, so we can, so pwede na siya walay M sub R sa because since we are analyzing one force as of the moment. So moment about O is, again, that's force times the perpendicular distance. So 100 times 2. So again, be comfortable with writing the units in the final part. So don't forget to write it in the final part. So answer is 200 Newton per meter. So don't forget the family name of your final answer. So dapat na siya unit, diba? So di lang kay 200 ang inyong ibutang, but place it with its unit. So in figure B, so take note that we are getting the moment at point O, and the force here is in this direction. So again, since the description of your moment is force times the perpendicular distance, so this one is the force. So the perpendicular distance is 0.75. Okay. So if we try to transfer your force here, so let's say na diri ang 50 newtons. So this will be our 0.75, di ba? Okay, it's in the same line of action man. So bala ato siya ibutang dito sa tumoy, di ba? So 0.75. So moment about O is force times distance. So that's 50 times 0.75. Then the answer for that one is 37.5. So 37.5. So again, don't forget the unit, Newton per meter. So force times the perpendicular distance jud. Okay, so in figure number 3, in C, so we have a 40-pound being applied at this point. Then we need to determine the moment at point O. So again, this one is the force. So the perpendicular distance of the force is this one, di ba? Kani siya na. So ato lang butas mabuo kay para inyo ma-imagine na sumpay siya sa force. It's connected to the force. So notice that this one is 4 meters, 4 feet, and the remaining distance, since let's say you don't know this one, diba? 2 feet, then you have the 30-degree angle. So to determine this side, so that will be the right triangle, diba? So 30 degrees, this one is 2 feet. So this one is 2 cosine 30 degrees. Cosine na function, diba? So meaning the total distance will be, so if we're going to solve for the moment about O, so that will be force times the distance. So the force is 40 pounds, and the distance is 4 plus 2 cosine 30 degrees. So the moment about O is 229.28 Newton. Hindi na siya Newton. That will be pound per feet. So pound per feet or foot, pound per foot. Diba? Murag yung magka-physics ani. Yeah, I don't know if not to be judgmental, but of course, nag-arky man ta, di ba? Kay may matag mga, we are creative, di ba? We have creative minds. So muna, ang purpose nga ng engineering ko kay di mo ako creative. So, basin mahagmo lang ko sa design, di ba? Kay labi na, I think, naman siguro na yung painting inyo, di ba? Nang murag, sa VSTEC mo siguro na subject. Kalimot ko sa na yung akuan. So, drawing simbahan, di ko bawa na. So, basin mahagmo lang ko, ana. So, dili lang ta sa mas maayo ta, di ba? Okay, so notice also there in the figure. So you have a shadow in the figure. So notice this figure here. That will be the behavior of the material. If we imagine the behavior of the moment, so also see the bending here in figure number 2. In figure B, mo na siya ang bending or the twisting or the um, rotating behavior of the figure. So also here. Okay, so next is figure D. So this one is force times distance again. This one is our force. So again, if for us to be not to be confused, so you can transfer your 60 pounds closer to point O, and then this will be the distance that you need to determine. Okay, so I think this one is 1 sine 45 feet. So if you don't know where it came from, so if you draw a right triangle here, so let's place it below. So right triangle. So 1 is your hypotenuse. This one is your 45 degrees. So this is 1 sine 45 degrees. So moment about O, that will be force times distance. So force 60 pounds times 1 sine 45 degrees. So the moment about O is 30 square root of 2. So 30 square root of 2 pound per foot. Or in decimal places, that will be 42.43 pound per foot. Okay. So simple lang kayo no, marag kaingon sa tanga way mas lisod ani sir, ba? So dito mo lisod-lisoron kay bisa na ba tama yung drawing, di ba? So again, that will be the behavior of the material. So of course it's going upward because the moment is of course counterclockwise. So that will just this is a kuan lang a approximate kanang kuan diagram of the behavior of the material. So base hindi mo ana siya, di ba? Yang kani mo straight ang tumoy kay yung gibira niyang kain dapita, di ba? You put this part here. So probably instead of may mo siyang straight, may mo siyang ana, di ba? Or to better imagine your this diagram, so try getting a bendy straw and then applying a force of, let's say bisag unsa nga force, so let's see if the behavior is in this manner. Okay, so in the last diagram, so we're going to determine the moment about point O with a 7 kilonewton force. So again, the formula is force times the perpendicular distance. So if we try to place the 7 newtons here, since this one is the same line of action, so our distance, instead of 4, it becomes 3, because this will be the perpendicular distance. Diba? Sakto, diba? Sa mo tong ni-raise og hand, sa may Um, 3 feet can be ignored since the definition of your torque is force times distance. So since your 3 feet is the same axis as your um, 60 pounds na force, so you can just ignore your 3 feet. So we just need to follow the description of your moment. So that will be force times the perpendicular distance. So probably the distance that the problem will show you is just for confusion, so that you'll be able to utilize wrongly the diagram. So for example, in figure number 2, so notice that we ignored the 2 meters, diba? Because the perpendicular distance of the 50 Newton force in figure B is 0.75. So what we need to utilize here as the distance is the 0.75. As long as it's the perpendicular distance of the force, so that's what you need to use as your distance. Okay. Okay, you're welcome. So basta as long as it's perpendicular, so the other distances, you can ignore the other distances being presented in the figure. So muna siya, you just draw a letter L na nabasa mo ana jud na siya na. So this may be the force and then the other one may be the distance, or vice versa. So this could be the distance, then this could be the force. As long as you create a 90-degree angle with the force and the distance, so your calculations will be correct. So for example, in the last figure, so for example, this one is the 7 Newton. So of course, since this one is point O, and notice that 7 kilonewtons is far from point O, di ba? So for us to be able to appreciate fully the moment concept, so let's try to transfer your 7 kilonewton, since this one is its line of action, di ba? So let's try to transfer it here. So this one is your 7 kilonewtons. So again, since the description or the definition of your moment is force times the perpendicular distance, so the perpendicular distance is this one, di ba? Perpendicular distance meaning it creates a 90-degree angle. So, pili po siya bali na L, di ba? So this will be your 7 kilonewtons. Then this will be your distance, which is now 3 meters only. So 3 meters only because your force is up until here only, and 4 meters is up until the tip of this diagram. So 2 meters, so you can just ignore 2 meters because there's no use in calculating for that distance. So 7 times 3, so moment about O is 21 kilonewton per meter. So, do you have questions? So, na-shock ka to kanina da kay pag-upot na ako nga kaning kuan. Pag-upot to nga feature sa Google Meet katong raise of hand. Murag karon pa ko ato ka experience. All right. So, if do you have questions? Ako naswayan daw ako mo raise of hand. Bitaw no? Sige, so I think there's no question. So let's proceed with the next. So of course, I think you can verify the answer. So 200 and then 200, 37.5, 229.28, 42.43, and then 21. So what I forgot in my calculation in the previous slide is the direction of the moment there. So you need to draw the arrows then, arrows in your final answer. So if you don't want to draw the arrow, so you can represent it using a negative sign if it's rotating clockwise. So for example, in the first 3 figures, so instead of putting the arrow, so you can represent it as negative 200 Newton per meter, negative 37.5 Newton per meter, then negative 229 pound per foot. So again, as stated earlier in the other slide, so as a sign convention, so everything that is rotating counterclockwise is positive and everything rotating clockwise is negative. So that's why we can represent it in this manner also. So negative 200 Newton per meter. Or if you don't want the negative sign or positive sign, so you can just draw the rotation. So kano siya. Okay. So let's try to analyze a system with more than two forces, diba? So we are familiar already with resolving forces, vertically and horizontally. So in the previous example, so patikim na to siya on how you solve the moment of one force. So how about we're going to get the moment of the resultant moment of the different forces. So let's try to solve this one. Okay, so natay chitan. So our aim should be our answer is 334 Newton per meter. So again, as the previous slide has taught us, so we need to approach our figure, our moment of the force, um, one force at a time, diba? So we're going to solve one moment first, and then another moment, and then the next moment, and then we add them all up in the final answer as a resultant moment. So here is we have four forces. So one, then two, and then three, and then four. So let's say this one is force one, force two, force 3, then force number 4. So usually, if we try to solve this one, so the resultant moment, m sub r, about point O, should be the sum of the different moments being created by these forces. So that will be, let's say, moment 1, moment 2, plus the third moment created by the third force, then the fourth moment created by the fourth force. Okay, so in algebraic terms, so force 1 times distance number 1, force 2 times distance number 2, force 3 times distance number 3, force 4 times distance number 4. So looking at force number 1, so this one is our line of action for the 50 kilonewtons. 50 Newton force. Diba? So para mas ma-appreciate niyo ang pag-get sa perpendicular distance, so I suggest that you expand fully or you expand fully the line of action of your force so that you can target the perpendicular distance. So for example, this one is your 50 Newton force, then this one is point O. So the perpendicular distance is 2 meters. Diba? Okay? So next is the force number 2 na sita. So for moment number 1, so we can solve the first moment. That will be F1 D1, diba? That's 50 newtons times 2 meters. So the first moment is 100 newton, 100 newton per meter. Okay? So in force number 2, so let's try to extend the line of action of force number 2. So notice that since this one is in the x-axis and it's the same line of action as your distance, or you cannot create any perpendicular distance from point O, di ba? Kaya inline siya sa point O. So meaning there's no distance. So meaning our moment 2, uh, so 60. So since there's no perpendicular distance, so our moment 2 is 0. So next is force number 3 na sada. So again, extend the line of action of your third force na para makita ang katag sa inyo third force. So kung what will be its perpendicular distance. So again, this is point O. So this will be the perpendicular distance. So this distance here is still unknown, but looking at the diagram, so we have a 30-degree angle here, and then we have a 3 meters distance being given in this direction. So we can create a right triangle out of this figure. So this is 30 degrees, then this is 3 meters. So getting distance number 3, so that will be sine, di ba? Sine. So sine theta is equal to opposite side over adjacent, over hypotenuse. So that will be d3 all over 3 meters. So d3 is equal to 3 sine 30 degrees. So solving the third moment, so that will be force number 3 times distance number 3. So that will be 20 newtons times 3 sine 30 degrees. So your third moment is 30. 30 Newton per meter. So lastly is your fourth force. So notice that if you extend the line of action of your fourth force, so this is the line of action of the 40 Newton force. So the perpendicular distance is this one. So that will be this distance, diba? This is the fourth distance, d4. So 2 meters, 2 meters, then an unknown distance which can be solved using this triangle. So cosine theta is equal to d4 all over 3. So d4 is equal to 3 cosine 30 degrees. So your fourth force can be solved by F sub 4, D sub 4. Then you have 40 times 3 cosine 30 degrees. So that is your M4. So this will be 103.92 Newton per meter. So what we forgot to apply in our moments is the direction. So going back in figure number 1, in moment number 1, so force times distance. So the rotation is in this direction, that's clockwise. So this one is clockwise. Moment number 2 is 0, so you can just ignore this one. Moment number 3 is counterclockwise. Diba? Counterclockwise. So if you try to push, diba? If you try to push your force with a distance, so the direction of its flip is kung muna siya yung rotation. Then moment number 4 is clockwise. Okay, so if we get the resultant, so resultant moment about point O, that will be negative 50, maybe negative 100. So let me just erase this one for a while. So negative 100 minus, let's say plus lang, 0, the second moment, plus the third moment, since it's counterclockwise, that's positive 30. Diba? Then the last moment is negative, negative 103.92 Newton per meter. So looking at our answer, murag kuwang siya, no? So sa may kuwang sa tong kuan. Or maybe the answer is wrong siguro. So 0 plus 30 minus 103.29. So wala yun siyang answer. So the answer should be negative 173.29. So dapat mo na siyang answer. Or 173.29 Newton per meter. And then since it's negative, so put the clockwise direction. Okay, so I think this one is the wrong answer. Kaya I think, okay, since murag ira ning gi-add tanan siguro. So let's try adding up. Now if we try to add up, so the total should be kuan, it should be 233.92. Or maybe ang yung answer is the 50 Newton is multiplied by 4. Maybe the murag mo na yung line of action of for the 50 because if nadiri ang 50, so the moment 1 becomes 200. So negative 200 plus negative 103. Murag basta sayop ni siya. So just verify the answer lang on your own. Okay, so let's see if sige na raise of hand. Sige. Moment number 4 is clockwise, no? Kuwang de. Let's see, be. Sakto de. Kuwang de ang distance. So, thank you kaya ato. So, kani mo excited ko good. Excited na kayo ma-answer, no? So, thank you kaya to. Sakto ba? Theories, no? Theories ba to? So plus 4 pa din nila ay. So, sayop ti atong pag-calculate. So, ako siguro gidoka, no? Lami king lunch ganina, good. Okay, so let's try. Sabi? 3 cosine. Yeah, times 40. Murag sakto na siya. 263.92. Then this one is minus 263.92. So sakto na siya. So the answer should be, so thank you kayo, Therese. So the answer should be 333.92. Negative 333 point, baliday. This one is negative, this one is positive kay nanay arrow, di ba? So this is your final answer. Alright. So sakto day itong answer day, sakto day. Ako day sayop. Sakto din siya. So gi-round off lang siyang answer. Okay, it's coming from the book. Okay, so questions so far or clarifications regarding the example? Okay, so understand. So let's proceed. So di siya sitwer ka, wala siya ka na example na gyapon siya. Okay, so a second example is this figure. So still at point O. Still at point O. So we need to get the moment about point O. So the force is 400 newtons being applied at this point at a 30-degree angle. So this is where your last topic comes into play. So we need to resolve the forces into its vertical component. So again, since it's going down to the right, so meaning it's going down, the vertical force, then it's going to the right, the horizontal component. So we need to resolve that into its different components for us to be able to determine the moment. So unless you have generated or you be able to solve the distance, the perpendicular distance from point O in this figure, which is, I think it's difficult, diba? So the easier way for us to do is to resolve its component and then multiply it with its corresponding perpendicular distance, which is a bit easier since we have distances coming from the horizontal and vertical component going to point O. Okay, so resolving the forces. So again, this one is our resultant force, 400 newtons. So again, if we try to resolve this one into its horizontal component and vertical component, we can create a right triangle but with a 30-degree angle. 30 ba? The 30-degree angle is, so the 30-degree angle is in this direction. Okay, so ano diha man, because of course translation of axis. So if you're going to use the figure, so if you want your 30 angle to be in that manner, the same as the figure, so drawing again your resultant force. So sorry kay sa kuan na sa drawing nga murag dili kayo approved by kuan College of Architecture. Noon sana may kong drawing eh. Okay, so for example, this one, ay, samot. Na, di ba? Bahala na siya, balag hiwi. Balag di siya parehag kuan. So let's say this one is our 400 Newton. So if you want to utilize the same angle as the given figure as the one in the right side, so this one is our vertical force. This one is our horizontal force. So we are still utilizing the head to tail concept. And then this one is the same as the figure, 30 degrees. Okay. So again, this one is our horizontal component. This one is our vertical component. So using the concepts of trigonometry, so we can solve for the horizontal component and the vertical component. So let's solve for the horizontal component first. So since this one is opposite the angle, the horizontal component is opposite the angle, so we're going to use the sine function. So sine theta is equal to f of h all over the hypotenuse, which is 400 newtons. So this one is sine 30 degrees is equal to f sub h all over 400. So f sub h is equal to 400 sine 30 degrees. So the horizontal component is equivalent to 200 newtons. Okay. So usually, if shortcut versions, yeah, since you know that your force triangle is a right triangle, so you can just use Pythagorean theorem in solving for the vertical component, diba? But if you don't want to use the Pythagorean theorem, so of course you're going to use the cosine function. Since your vertical component is adjacent to the angle, so cosine theta is equal to adjacent side, that's the vertical component, all over the hypotenuse, that's the 400 newtons. So cosine 30 degrees is equal to the vertical component all over 400 newtons. Okay, so the vertical component is equivalent to, so this is 346.41 newtons. So again, if you have solved one force, so you can use Pythagorean theorem. So let's say FV is equal to the square root of 400 squared minus 200 squared. So I think the answer is also the same. Oh, so 346.41 gapon, di ba? Okay. Now, since you know your horizontal component and vertical component, So we can say that we can generate two moments for this one. So one moment will be coming from this force, the horizontal force, and then one moment coming from the vertical component. So let's try to, ayay ka. Ano naman to taon eh. It's a, mag na-erase na nun. May erase lagi ito, no? Sige lang. Ato lang sa waton balik. Ato lang amboy na naman siya. So, kahit sa nawa dyan siya. Bot lang dyan ato. Sige lang. So, sa to, ang horizontal force is 200 newtons. And then the vertical force is 346.41. So if we try to determine the moment, so again, the resultant moment about point O. So we're going to have two moments. So that will be coming from the horizontal force times its perpendicular distance plus the vertical component and its perpendicular distance. So let's try to solve the first moment m sub 1. Okay, unsa naman to? Unsay kanang question? Na presenting ko? Akong ikaw na. Okay. Okay na? Okay, so muna siya. So horizontal component as solved earlier, 200. And then vertical component, 346.41 newtons. And then for the two moments coming from the two forces, so that's m1 plus m2. So solving first the moment created by the horizontal force. So if you try to extend the line of action of your horizontal force, ano siya, di ba? So the perpendicular distance is this one, which is your 0.2 meters. So 200 times 0.2. So moment number one is equivalent to 40. So 40 Newton per meter. So if you try to imagine the rotation of your horizontal component with the perpendicular distance, so that will be counterclockwise. So yun siyang ma-imagine, di ba? If this distance is pushing this force, so the rotation is going in this direction. Okay? So next is we try to extend the vertical force so that we can solve the second moment. So this is the distance from point O with the vertical component. So this is the 0.4 meter distance. So the second moment is 346.41 times 0.4. So the second moment is 346.41 times 0.4. That's 138.66 Newton per meter. And then notice that if this distance pushes this force, ba? Or let's say the force is pushing this distance either way. So the rotation is clockwise, di ba? Mana siya, clockwise. So clockwise. So the resultant moment about point O. So the first moment is positive 40 Newton per meter. Then the second moment is a clockwise moment, that's negative 138.66 Newton per meter. So the resulting moment about point O is 98.66. So that's the same as the answer, 98.66 Newton per meter. So that's clockwise direction. Or if you want to write it in terms of its signage, that's negative 98.66 Newton per meter. So this is the final answer. So sorry kaya about atong kuan but mag-glitch ako ang presentation. So do you have questions for this example? Alright, so if you don't have any questions, so example number 6 will be your assignment. And take note that you have two forces. So this is 200 kilograms. So notice that 200 kilograms is still not a force, but this one is still a mass. So you need to multiply it with gravity first to get the force. Okay, so this one is 165 kilograms. And then notice that the distance per box or per grid is 0.3 meters. And you're going to take 4 moments. So even though it's one problem assignment, but you are going to take moments from 4 points, A, B, C, and D. Okay? So again, I suggest that you first resolve your components into its horizontal and vertical component. So in this manner here, kung i-present. And then you take moment again from point A first, and then point B, point C, and then point D. So kana at least ma-practice po yung drawing, drawing mo kanang kuan, mga grid lines. Okay? So any further questions or concerns or sa panadya inyong mga kaligot-got and mga kuan? Okay, so if there's no question, so I think that's all for today. So the deadline for your assignment will be next Tuesday. Sige na itong deadline sa assignment gani? Every Thursday ba na? Or every Tuesday? Every Tuesday, no? Sige, ako lang tanawon sa Canvas. Okay, so if there's no question, so I think that's all for today. So thank you very much for listening and see you all next Thursday.